Hello, Mr. Hind here. Talking about end behavior in this video, just so I get a little bit comfy. Um, Preview of it, I know, and hopefully this helps apply to any of the problems if you need this and are watching the video. If not, please email and ask an office hours where I will definitely answer your specific question. So end behavior is what's happening to the function on the far left, and far right. All right, which in math words we talk about is what's happening to the function as x approaches negative infinity, and what's happening to the function as x approaches positive infinity. All right, so it's the limit as x approaches negative infinity and the limit as x approaches positive infinity of the function. Focus that in, sorry. All right, so that's really what end behavior is we look at, we want to predict an applicability, we want to predict what would happen 50 years from now. I guess that's not really end behavior, but maybe 5,000, 5 million years from now, which you get into space. And it's so fascinating. I'd love to talk to space with any of you about it. That's when this really comes into play. So we're going to look at an example here so I can kind of show you how this looks. So let's look at f of x is equal to, let me see here. We'll do 2x plus 1 plus 1 over x. A very odd function. Right? Now, graphically, if we were to use a graphing calculator or Desmos, remember you can use a Desmos too as an option. If I put this in, let's see what it looks like. So we're going to do 2x plus 1 plus 1 over x. Put in extra parentheses, I really need to there. And graph. It looks like it does something like this, where you have a vertical aspect is 0, because we can't plug in 0 here, because if you plug in 0, you can't divide by 0. And the graph looks something like this. And the question is what's happening on the far right? If we were to keep looking at the far right of the graph and the far left of the graph, way over here, what's happening? And you could zoom out in Desmos or your calculator and you could say, oh man, it looks like it's following this line. Well, what is this line here? Right? You could try and figure out the slope. You could figure out the slope of that line by picking 2 points. And then work backwards from there to get the starting value. Or if you watch my video on point slope form, that's actually the easiest, where pick 2 points, find the slope, and then just put it in point slope form. And that would tell you the end behavior, the function that it's approaching. Because keep in mind, end behavior, it sometimes approaches a number or another function, right? So graphically, that's how you do it. Now, algebraically, if we look at this function, f of x equals 2x plus 1 over x, if we wanted to look at the limit as x approaches negative infinity of f of x, the trick is you just plug negative infinity in, as with all limits, if they exist, that is. So it'd be like 2 times negative infinity plus 1 over negative infinity, which negative infinity is not a number, so don't get stuck in this that there's a number and I'm looking for infinity on a calculator. It's a concept. Well, if I'm at a really large negative number, like say negative a million, 2 times negative million is negative 2 million. Will adding 1 really affect that? Not really, not at all. So I'm still at a really big negative number. And now this is where fractions matter, 1 over negative infinity. Well, if a number, the denominator keeps getting bigger, like break it down into something small. Like if I looked at 1/2, 1/3, 1/4, 1/5, 1/6. What's happening as that denominator gets bigger? Well, 1/6 is very tiny versus 1/2, which is a little bit more. So as the denominator gets bigger, this actually goes to 0. So this right here is actually going to approach 0, right? So then what happens is all this just gets smaller and smaller and smaller, negative 2 million, and it just keeps going. as we get smaller and smaller, get to negative 5 million, negative 10 million, negative 10 billion. So this, in fact, equals negative infinity. We could say is the limit as x approaches negative infinity of f of x, it's going to equal negative infinity. And you can see that from a graph, it's going to go down forever. And then the limit as x approaches positive infinity of f of x is actually going to be the same thing here. Nothing's really going to change. And you don't need to write this, I'm just writing it down. That's going to go to 0 because 1 over a denominator keeps getting larger, right? 1/10, 1/100th, 1/1,000,000th. That part, like 1/1,000,000th of something, is going to be so tiny. So that's going to go to 0. And this is just going to keep blowing up. So that equals infinity. Okay. But as for if you wanted to know, like, okay, if you look back at this graph, what line is it approaching here? Because we know it's approaching a line. If you want to be more specific, what line is this? Well, what's interesting is that if you remember, if you look at infinity, this actually just kind of disappears. This doesn't matter in the long run. And all that actually stays is the function right here. So in fact, this line right here is y equals 2x1, which is a slant asymptote. And there you go, which usually gets slant asymptotes when the limit as x approaches negative infinity of the function, or the limit as x approaches positive infinity of the function equals negative plus or negative infinity. Because then you're saying it's going to negative infinity, but at what angle? Which, when you talk about angles, that's why it's a slant. Or if it was a number, it would be just a horizontal asymptote, which they kind of work hand in hand. All right. So that's just a snippet. I could go into more detail, but I don't want to take away too much from your learning. And I only want to give you enough so you can still figure out yourself, because that's where the real learning will happen for you. If you have any questions, definitely feel free to email or come to office hours. Bye-bye.